if something walks by this thing, they're making it sound like the orientation of this sensor is critical. You know, because that's what this thing is saying. That you know, because it has like 2 sensors, and they're making it sound like the orientation is critical. The bad thing about that means if you're going to use it, you need to absolutely make sure its orientation is right, otherwise it won't work. But beyond that, and see, they're the 2, there she is. Here are the 2 different sensors, and they're making it sound like the orientation has to be like that, because that's what they're showing. You read through this thing, right? That's what they're showing.
Yeah.
This thing is going to walk by. It's going to come through this sensor first, and then that one.
So there's like 2 sensors in that PRI thing.
That's correct.
Okay.
There are 2 sensor structures in it, and what happens is, and I don't quite understand why the second one leads to a deflection down, because like the first one causes a peak up, and then the second one creates a peak down, and then it has like this MOSFET inside of it, and that MOSFET detects the change in charge in this thing.
Okay.
But your circuit, did you guys analyze this thing? This is actually a filter right here. This thing's actually a filter.
Okay.
That's a filter, and this is a filter.
Okay.
And this is a comparator, and this is a comparator. What happens is when this voltage right here, the voltage right here is greater than this voltage, it's going to turn on and pull this node up to this voltage minus the voltage right across that diode. And then if the voltage drops below, if this voltage right here drops below that voltage, then that'll turn this one on. I don't know if you looked at it, because this right here is like a reference leg.
Okay.
Because what it is this is a voltage divider. See, this is 1 meg, and that's 1 meg.
Yeah.
Which means the voltage across both is the same. And then you have the diode drop, which you can assume like 0.7. Okay, so you have 0.7. You have 0.7 plus 0.7, which is 1.4, minus whatever the voltage is, all that divided by 2 meg, and then you multiply that current by 1 meg. That's going to give you the voltage across this resistor right here. And that voltage minus the supply voltage will be the voltage at this node.
So do you think that it'll do what, do you think it'll do what we want it to do?
Yeah, it will. This one shot, what it does is, when it sees something, you know what a one shot is? You guys thought about a one shot is something where you fire it and it'll stay on for a finite amount of time, then it'll shut off.
Okay.
So because what it does, it only has one stable state, which means that whatever state it goes into, it won't stay there indefinitely. It'll go there momentarily and then fall back.
Okay.
So that's what this thing right here is doing.
Okay.
And the question is that what you want this thing to do? To come on and then to shut off, because that's what it's going to do.
Okay.
That's what this circuit right here does.
Okay.
Okay. So what happens is this thing senses something, then it takes that sense event, fires this one shot, and one shot comes on for a certain amount of time, then it'll shut off. And that's all this thing is going to do. Is that what you want it to do?
I think because we want it to go from like light to deep sleep.
Yeah, but what I'm saying to you, this thing will wake up, and then if it's turning on a computer, it'll go back to sleep. So it's like the person sitting in front of the computer, and it'll just go back to sleep. Because if you look at this thing right here...
So it'll wake it up, but then once the person's on the computer, it'll turn off?
Well, that's what it seems to be suggesting from what... Because if you look at this right here, and I guess if something stays in front of it, I guess it'll continually sense it. Mm-hmm. And I guess that's what you're assuming.
Yeah.
If it continually senses this thing, this one shot... I wonder if it sees a continuous event. If you have a continuous event, you don't need the one shot. Let me show you guys what a one shot does. I don't know if you're familiar with that. That device or that structure.
Is that transformer like with the
Right here?
shot?
No, that's actually a relay.
Okay.
Do you know what a relay is? Because I know a lot of these things you guys don't talk about because they're not.
And you said like we didn't need that, right?
No, you don't.
Okay.
A relay is used whenever you have two systems that need to be isolated from each other. Let's say you're trying to control 120 volts with 12 volts. Well, there's 12 volts DC is very different than 120 volts. And so what the relay does, it allows you to use one system to control something that's at a much higher voltage.
Okay.
One shot. So you don't need that. I should know you guys would have thought it was a relay. One shot. Start doing crazy stuff. This is a one shot. Monostable, multi-vibrator. That what it is. It's all one shot. With this and what a one shot does, if you look at this example right here, see this? It has this little event. So this fires this one shot, and it stays on for a fixed amount of time. So even though this event is very small, it will stay on a fixed amount of time and then go back off. So what it does, it takes like a narrow pulse and makes it much wider. And so what this thing is doing is something will fire this circuit, and it'll come on a certain amount of time and then go off.
But if the person's still sitting there, it'll stay on?
And it'll stay on because the event, the signal is going to stay high the whole time.
So after they leave, it'll go off?
In a certain amount of time, yeah.
And that's what we want.
And
Okay.
That's what this R10 and C6, they're actually determining the time constant. If you look at this circuit right here, you actually have this RC time constant thing going on, where you charge a cap and then you look at the amount of time it takes to discharge. Let's see. But that's what this chip is. It's a one shot.
Okay. All right, I think